Hello everyone, my name is Urvisha Patel, working as an assistant professor in Computer Engineering Department at Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Today we are going to learn unit number 5, Concept Description and Association Rule Mining. What is concept description? Data mining can be classified into two categories. First is descriptive data mining and second is predictive data mining. Descriptive data mining is used to describe the data set in a concise and summarized manner. Descriptive data mining is used to present interesting general properties of the data. Concise means giving a lot of information clearly and in a few words. Another one is predictive data mining. Predictive data mining is used to analyze the data. After analyzing the data, we will generate the model. Using this model, we will predict the behavior of new dataset. The simplest kind of descriptive data mining is called concept description. A concept usually refers to a collection of data, such as frequent buyers, graduate students, etc. Concept description generates descriptions for characterization and comparison of data. It is also called class description. Characterization provides a concise and brief summarization of the data. As I said, concise means giving lot of information clearly and in a few words. While concept or class comparison, you can also say discrimination, provides discrimination comparing two or more collection of data. Concept or class comparison is used to compare two or more collections of data. Next is basket analysis. Market basket analysis is a modeling technique. It is an example of frequent item set mining. This process is used to analyze customer buying habits by finding association between the different items that customer place in their shopping basket. Like if you are in a store and you buy a car, then you are more likely to buy insurance at the same time than somebody who didn't buy insurance. The set of item a customer buys is referred to as an item set. If customer 1 is buying a 3 item 1, item 2 and item 3, then this 3 item is known as an item set. This analysis is used to find relationship between purchases of item. If X person is buying car and accessories, then that person will buy insurance. This example is used to find the support and confidence. The probability that customer will buy a car without an accessories is referred to as the support. In next PPT, we will see the example to find the support. The conditional probability that a customer will purchase insurance is referred to as the confidence. In this market basket analysis, you need to remember three things. This is a rule. If X person is buying a car and accessories, then that person will buy a insurance. Then here we are finding two things, support and confidence. Next is association rule mining. Here you can see the database of the transaction. Total 5 transactions are there. Means here you can see the 5 basket 1, 2, 3, 4, 5. Customer 1 is buying bread and milk. Customer 2 is buying bread, chocolate, Pepsi, eggs. Customer 3 is buying milk, chocolate, Pepsi, Coke. Likewise customer 4 and customer 5. These are the association rule. If X person is buying a chocolate, that person will buy a Pepsi. We need to find the probability of these rules, and we need to find the support and confidence of this rule. If X person is buying a milk and bread, that person will buy eggs and Coke. If X person is buying Pepsi and bread, then that person will buy milk. So these three are the rule, and we need to find the probability of these three rules. First is item set. A collection of one or more items are called item set. Example, milk, bread, chocolate. This is called one item set. Key item set means an item set that contain key items, key number of items, that is called key item set. Next is the support count. Support count means frequency of occurrence of an item set. Here we are taking one item set, milk, bread, chocolate. And in this transaction database, we are finding the frequency of occurrence. In transaction 4, you can see milk, bread and chocolate. So one occurrence. In transaction 5 also you can see milk, bread and chocolate. So total 2 occurrence. So support count of milk, bread, chocolate item set is 2. Next is support. Support means fraction of transactions that contain an item set. Here I am taking same item set, milk, bread, chocolate. 2 means total 2 transaction we have. In that transaction we find milk, bread and chocolate. Divide by 5. Divide by 5 means total 5 transactions we have in our database. Frequent item set. Frequent item set means an item set whose support is greater than or equal to a minimum support threshold. That is called frequent item set. So total 4 point item set, a collection of one or more items, support count, frequency of occurrence of an item set, support, fraction of transactions that contain an item set, frequent item set, an item set whose support is greater than or equal to a minimum support threshold. Minimum support threshold is always given in the example. Association rule. Here, association rule is represented by X tends to Y, where X and Y are item set. Example, milk, chocolate and Pepsi. This is the example of association rule. Rule evaluation. For rule evaluation, we need to find two main parameters, support and confidence. Support of transactions that contain both X and Y. Support means fraction of transactions that contain both X and Y, means left side of the rule and right side of the rule. Confidence means it is a measures how often item in Y appear in transactions that contain X. Let's see one example. Find support and confidence for milk, chocolate and Pepsi. This is the association rule. And we are going to find support and confidence for this rule. This is our transaction database. You can see milk and chocolate in 3 transactions. Transaction 3, 4 and 5. And you can see milk and chocolate with Pepsi in 2 transactions. Milk, chocolate, Pepsi, transaction 3 and milk, chocolate, Pepsi, transaction 4. Support of rule is equal to 2 divided by 5, means if we have total 5 transactions and in 2 transactions we can see milk, chocolate and Pepsi together. So 2 divided by 5 is equal to 0.4. This is support. Confidence. Confidence means we have 3 transactions, in that we can see milk and chocolate both together. Transaction 3, transaction 4 and transaction 5. Total 3 transactions we have, in that we can see milk, chocolate together. And from 3 transactions only 2 transactions are available, in that we can see milk, chocolate and Pepsi together. So this is called confidence. We can also calculate support and confidence for all the rules. Here you can see some association rules. Here support is equal to 0.4. Support means Suppose I am taking milk, chocolate and Pepsi. So you can see only two transactions with milk, chocolate and Pepsi, right? But total we have total 5 transactions in our database. So 2 divided by 5 is equal to 0.4. Support is equal to 0.4. Likewise, milk, Pepsi, chocolate, chocolate, Pepsi and milk, chocolate, chocolate and milk, Pepsi, milk and chocolate, Pepsi. For all these rules, support is equal to 0.4. 2 divided by 5. Okay. Next is confidence. For this milk, chocolate and Pepsi, we have total 3 rules with milk and chocolate, and total 3 transactions contain milk and chocolate, and only 2 transactions contain milk, chocolate and Pepsi. So confidence is equal to 2 divided by 3. Same way here you can find the confidence for all other rules. Many association rule mining algorithms is decompose the problem into two major subtasks. First is frequent item set generation and second one is rule generation. Frequent item set generation means in which we need to find all the item set that satisfy the minimum support threshold. Minimum support threshold is already available in the exam. These item set are called frequent item set. Rule generation means to extract all the high confidence rules from the frequent item set found in the previous step. Means in frequent item set generation, you need to write all the rules, and then from that rules you need to extract all the high confidence rules from the frequent item set generation. These rules are called strong rules. Apriori algorithm is one of the frequent item set mining methods. Apriori algorithm is used to find frequent item set by confined candidate generation. Here you need to remember main three key concepts. First is frequent item set, that is denoted by Li. Li means the sets of the item which has minimum support. Next is a priori property. This property is used to improve the efficiency of the level-wise generation of frequent item set. And next main point is join operation. To find the LK means the set of item which has minimum support is denoted by LK for kth item set. To find LK, a set of candidate K item set is generated by joining LK plus 1 itself. To find the frequent item set, first point is the set of item that have minimum support, and a subset of that item set, frequent item set, must also be a frequent. Means all non-empty subset of a frequent item set must also be frequent. Means if item set AB is frequent item set, then both A and B item set should be a frequent item set. The pseudocode of Apriori algorithm contain two steps. First step is join step. Here CK is a candidate set generated by joining Lk-1 with itself. We will see in detail. Next is a prune step. Any K-1 item set that is not frequent cannot be a subset of a frequent K item set. First step of Apriori algorithm, we are making the candidate set with item set containing just a single item, means only individual items. Step 2, in step 2 we need to determine the support for item sets. Support means frequency, and then compare the support of item set with minimum support threshold. If item set do not support minimum support, then remove item set. Step 3, in step 3 you need to make the combination of item set. Step 4, repeat step 1 and 2 until there are no more new item set. These are 4 steps. In pseudocode, CK is a candidate item set of size K. Lk is a frequent item set of size K. L1 is equal to frequent items. And here we are repeating the step 1 and 2 till the end. In this pseudocode, in this for loop, first we are calculating the L1 means frequency of the item. Then comparing the set with minimum support count. If the support count of the item set is greater than minimum support, then we are considering the item set. Example of a priori algorithm, minimum support is equal to 2, which is already given in this example. This is our data set, capital D. In this we have transactions. Transaction IDs are 100, 200, 300 and 400. And in second column we have number of items. In first step we need to scan database D. After scanning database D, we are generating C1. Means after first scan, we are generating candidate set C1. As per the step 1, here we are taking individual items as a set. So total 5 item we have, item 1, item 2, item 3, item 4 and item 5 in our database. In second column we are calculating the support. For item number 1, here support is equal to 2. Means in two transaction we can see item number 1. In transaction ID 100 and in transaction ID 300 we can see item number 1. So support is equal to 2. Item set 2, support is equal to 3. So in transaction database we can see 3 times item set 2. So support is equal to 3. Same way, support of item set 3 is equal to 3. Means total occurrence of the item is equal to 3. Support of item set 4 is equal to 1. So in only one transaction we can see item number 4. So support of item set 4 is equal to 1. Next is item set 5. In item set 5 is occurring 3 times in our database. So support is equal to 3. This is our candidate set. Now we need to compare our candidate set C1 with minimum support is equal to 2. So all the items containing support 2 or 3 except item number 4. So here we are removing item number 4 from the candidate set C1 because the support of item number 4 is less than minimum support threshold. Our minimum support threshold is 2. So remove item number 4 and generate L1. So we are selecting item set 1, 2, 3 and 5. Now in the next step we need to do the join step. Here I am generating candidate set C2 by combining the item set. In L1 we need to perform join operation. C2 first item set is 1 2, next is 1 3, next is 1 5, then 2 3, 2 5 and 3. Now scan C2 and write support in second column. Frequency of item set 1 2 is 1. Only one time you can see the item set 1 2 in our transaction database. Same way 1 3, 1 5, 2 3, 2 5 and 3 5. Now compare the item set and minimum support of the item set. Now compare C2 table with minimum support 2. Remove the column whose support value. Remove the column with support less than minimum support threshold. So here I am removing two item set 1 2 and 1 5. After removing the two item set, next I am generating the L2. Now perform join operation on L2 by scanning the L2 by performing the join operation. Here we are writing 4 item set 1 2 3, 1 2 5, 1 3 5 and 2 3 5. Now calculate the support from the database. Compare the support with minimum support. Here I am removing 3 column from C3 and generating L3. So only one row is available in L3. 2, 3, 5 with minimum support 2. So our frequent item set is 2, 3, 5. This is the answer of Apriori algorithm. Next is the rule generation. Using frequent item set 2, 3, 5. I am writing the rules. Here I am writing the 6 rules and calculating support and confidence. Support for all the rules are 2. Support means frequency of the rules. So 2, 3, 5 item set is available 2 times in transaction database capital D. Next calculating confidence. In first rule 2 and 3 tends to 5 means in our database, let's see the database. This is the transaction database, TID and items 2, 3 and 5. So we have total 2 transactions in which we can see 2, 3 and we have Also 2 transaction with 2, 3 and 5. So 2 divided by 2 is equal to 1, means confidence is equal to 100%. 3 and 5 means in our transaction database we have 2 transaction with 3 and 5, and we have also 2 transaction with 3, 5 and 2. So confidence is 100%, 2 divided by 2. Let's check occurrence of 2 and 5 in the database. Here in the transaction database, total 3 transactions are available with 2 and 5. And 2 with 2, 5 and 3 item set, only 2 transactions are available. So confidence is equal to 2 divided by 3. So here answer is 0.66, means confidence is 66%. Same way you can calculate the support and confidence for other 3 rules. Improve a priori's efficiency. These are the techniques. By using the techniques, you can improve the efficiency of a priori algorithm. First is a hash based item set counting, transaction reduction, partitioning, sampling, and dynamic item set counting. Thank you.